Second section, solving and graphing inequalities. To solve and graph inequalities and write solutions in interval notation is our objective. So here's some important things here. An inequality has more than one answer and uses the following symbols. Now, this is where people get confused. Whoops. This symbol right here is not less than. Okay? We call it that less than because we read left to right. And we say 2 is less than 5. But couldn't we say 5 is greater than 2? Yes, we could. So the thing is, since we read left to right in our language, most people will call that less than, but it's just an inequality. Just like we could write this way, 5 is greater than 2, but we could also say 2 is less than 5. We could say 3 is less than 12, but it also has this extra line here. So it's 3 is less than or equal. So in this case, I could put this, and it's a true statement. 7 is not greater than 7, but it is greater than or equal to itself. Now, to graph one variable, inequalities on a number line, we use open dots for less than or greater than, and solid closed dots for less than or equal, greater than or equal. All right? Now, here's the thing. The biggest rule you have to remember, you just need to mark this, circle it, put stars around it. Anytime you multiply or divide by a negative number, not anytime you see a negative number, just if you multiply or divide by a negative number, you have to switch the symbol. All right? And if there's no solution, like we talked about in the first section, we can also use this symbol, the 0 with a line through it. Okay? So we can also reverse things. X is less than 2. We also said 2 is greater than x. Well, we can write it like that. 2 is greater than x. We can switch the sides. All right. Interval notation. This is something new. Use interval notation to write solutions. We're going to use parentheses for open dots and arrows. And we're going to use brackets for closed dots. All right? So in this case, we're starting at -1. We're going towards infinity, positive infinity. We're going to put a comma between that, and since it's greater than or equal to, we're going to use a bracket. Okay? And we use parentheses for infinity because we really can't capture infinity. So the bracket means we're including -1. All right? Now look at this one. We're starting at 3, but notice we're going out here to the left towards negative infinity. So we put negative infinity on the left side. We put a comma. We can't capture infinity or negative infinity, so we use a parentheses. But notice the 3 is an open dot. We don't include the 3, so we use a parenthesis symbol. All right, now notice this one's different. We're between two numbers. The -5 has a solid dot, so we use a bracket. The 4 has an open dot, we use a parentheses, and we separate them with a comma. Now we're going the other direction. So we're going from -8 towards positive infinity, okay? So I don't have to put all the numbers on the number line. -8 is fine. If you want to think that positive infinity is out this way, that's fine. You can put that to remind yourself. Notice we have a bracket. That means a solid dot. I like to put mine above the line. That way I'm not trying to, shade over a line that's already there. Just makes it easier, I think. Notice this one. We're going towards negative infinity, so we're going to the left. So I mark -1. Notice it is a parenthesis, so that's an open dot. So I'm going to go this way towards negative infinity. And now I have two numbers, a 0 and a +7. I don't have to write 1 through 6 in between. I have a parentheses there, that's an open dot, a bracket there, that's a closed dot, and then I just connect them. That's it. That's all I do for those. All right, now we're going to do everything. Okay, we're going to solve and do the notation and graph it. Now notice, we have a negative number here in front of the x, which means we're probably going to end up dividing by -3. Okay, so I'm going to get rid of the 6 on both sides. That leaves me -3x is less than 12 minus 6 is 6. I'm going to divide by -3. As soon as you hear yourself say that in your brain, alarm should go off. In fact, I'm going to flip the symbol right now before I do anything else to remind myself not to forget. Because guess what? I do too. It happens. That gives me x is greater than 6 divided by 3 is 2, positive divided by negative is negative. Now let me just show you real quickly. You don't have to write this down, but watch what happens. I could have, it's a little bit more work, moved my 3x over to the right side. That would have given me 6 is less than 3x plus 12. Then I would minus 12 from both sides, and I would get 3x is greater than -6. And if I divide by 3 here, guess what I get? X is greater than -2, or -2 is less than x. That's why we flip the symbol. You can avoid it with more work by moving the negative coefficient over to the other side. It's just more work, but if you have a habit of forgetting that rule, that is an option. So, back to graphing. I'm starting at -2. It's greater than -2, so I'm going towards positive infinity. It is a greater than symbol, so it's open dot going this way. Now, one hack here that people have trouble with. You don't just go the order of the direction of the arrow. Because notice, if I graph this one, the direction of the arrow, I'd be going the wrong way. If you want to do that, you always have to read from your variable. So x is greater than -2, no matter which way you read it. So I'm going from 2 out to positive infinity. It is an open dot, so parentheses, and I can't capture infinity, so I put parentheses. All right. Number 8, there's actually a trick here. I can distribute this -4. I'll come back to it. I'm going to put this to remind myself. I'm going to distribute the -4. So that's -16x. 2 times 4 is 8, minus 8, less than or equal to -24. I'm going to add 8 to both sides, which is going to give me -16x is less than or equal to -24 plus 8 is -16. I'm going to divide by -16. As soon as I say that, I'm going to flip the symbol. X is greater than or equal to +1. Now, real quickly, I'm going to do this on another page. You don't have to write this down, but I want you to see there is a trick. Since the -4 is a factor of that -24, I can actually get rid of it first and have smaller numbers. So I'm going to divide by -4. Oh, as soon as I say that, I flip this. That gives me 4x plus 2 is greater than or equal to 6. I'm going to -2. And I get x is greater than or equal to 1, which is what I already had. So just notice, if this number is actually a factor of this number, you can save yourself some time. It's up to you. It's just a shortcut, not required. So I'm starting at 1, but notice I have a solid dot because of the greater than or equal symbol. It's greater than, which means I'm going out here towards positive infinity, which helps me with my notation. 1 to positive infinity. It's a solid dot. I use a bracket. I cannot capture infinity. I use parentheses. Okay, just a couple more and we're out of here. Now, think back to the previous lesson. See, I have these 3's here in the denominator. I can multiply everything by 3. And what it's going to do is cancel my 3's here, leaving me just n. 3 times 10 is just 30, greater than or equal. The 3's cancel, leaving me 2n, and negative 4 times 3 is negative 12. Okay? You can keep the thirds if you want, but it's a lot less work doing it this way. Now, here's what we want to think ahead. Remember I told you in the first lesson, some people like to keep their variables positive. Some people like to put them on the left all the time. If you subtract 2n, you're going to get negative n, which means you have to divide and flip the symbol. So personally, I like to stay positive. So that gives me 30 is greater than or equal to 2n minus n is 1n minus 12. I'm going to add 12 to both sides, which gives me 42 is greater than or equal to n. Now think about this. Remember in the very first notes we said we can just flip, turn everything around. Now remember, the sign is pointing towards the n, right? So this right now says 42 is greater than or equal to n. Or we can read it, n is less than or equal. So n is less than or equal to 42. Okay? Now just picture this in your head. If we would have started off by subtracting the 2n, that would have given us negative n greater than or equal. But then when we divided by negative 1, we end up with n less than or equal. So we're at 42. Solid dot, and less than or equal. Horrible line there. Remember, we're going towards negative infinity. We always put negative infinity on the left. 42, bracket, parentheses, that's it. All right, last but not least. Now, here's another trick. You can keep the decimals the way they are, but if you notice, they're both hundredths. So guess what we can do? We can multiply this entire thing by 100. You don't have to. You got calculators. You can use the decimals, add 0.12, which is like $3.86 plus 12 cents, which would be $3.98. Okay? Or you have the option of getting rid of the decimals and just have 15y minus 12 greater than 386. It really depends on what you want to do. It's up to you. You're going to get the same answer anyway. And you have calculators, so bigger numbers don't really matter. Oh, I forgot to show my work. I'm going to add 12 to both sides. So that's going to give me 15y is greater than 392. Sorry, 98. See, we all make mistakes. Now I'm going to divide by 15. Okay, so I'm going to do 398 divided by 15, which I cannot do in my head, so I'm going to use a calculator. And that gives me y is greater than 26.53 repeating. 33333. So I'm just going to leave it like that. So greater than means open dot. I just put 26.53 repeating. And it's greater than, so it's going towards positive infinity, which helps me with my notation. 26.53 repeating. It is an open dot, so it's a parentheses, and it's going towards positive infinity. And that's it.